Hi, and welcome to 5.1, different forms of linear equations. We are going to talk about two types of linear equations today. We're going to talk about standard form, and we're going to talk about slope-intercept form. Both of these you have seen before, but we just haven't given names to yet. Standard form is a line written like ax plus by is equal to c, where a, b, and c are any real numbers, and c are real numbers. So just numbers that you can think of, whereas x and y are going to be the variables, are real numbers. Normally, a, b, and c are integers, which means no fractions allowed, and a is usually greater than 0. So when you're writing this out, you're going to have to write it so that a is a positive number. Slope-intercept form looks like y is equal to mx plus b. This one is super convenient because we keep using m as the variable slope, and in this case, it is the slope. M is our slope, and b is actually going to turn out to be our y-intercept. We can take a look at Desmos for a second, and I've got this set up so that you can see what happens with y is equal to mx plus b. This one's really nice for visualizing what happens with graphs. I've got Desmos set up so I could take this b value, and notice how as I make b bigger and bigger and bigger, my slope stays the same, but it goes up towards the top. When my b is equal to, say, 7, my y-intercept should be 7, which you can see right up here goes through 7. Notice how it happens when I grab that slider and I move it left. This is where our slope changes. Negative slope, we go downhill to the right. Positive slope, we go uphill to the right. And if I just bring my y-intercept back down so we can see it a little bit better, maybe we drag it into the negatives. Notice how, again, steeper the bigger that number is, less steep towards 0, and then when it's negative, it's negative. Feel free to log into Desmos yourself and play with those a little bit. It's a handy little tool to take a look at. So as you can see, the slope-intercept form is a little bit nicer when you need to graph, but a lot of times when we talk about lines, it'll be given in standard form. A line can be given in both ways, and it could still be exactly the same line. So let's do a couple of examples. Let's look at changing from slope-intercept into standard form. So I'm just going to come up with any example here. Let's look at slope-intercept y is equal to 1/2 x minus 7. So the key, I think, to standard form is to solve for that constant, c. So in this case, we're going to identify the constant, which is this 7. That's going to be our step number 1. We're going to solve for the constant. So in order to get 7 all by itself, or in this case, negative 7, what I'm going to want to do is I'm going to want to move that 1/2 x. Since it's a positive 1/2 x, I can subtract 1/2 x from both sides. On my right-hand side, I've got a positive 1/2 x and a negative 1/2 x. So when I combine like terms, it's equal to 0. So on my left-hand side, I have a y minus 1/2 x is equal to negative 7. I am almost now in standard form. Unfortunately, I have to pay attention to these rules. both the integers and a has to be greater than 1. Well, notice how the coefficient with my x is a negative 1/2. It's breaking both of those rules. So in order to get rid of the fraction, what we have to do is we have to think about how we can get rid of that half. So if I was to multiply it by 2, that would get rid of the fraction. So I multiply it by the denominator. But I can't just multiply one term by something. In math, I can do everything to one side, and then I have to do the same thing to the other side. So I'm going to multiply everything on the left by 2 and everything on the right by 2. We'll notice how on the left-hand side I'm going to have to FOIL my inside and then outside. I'm going to have to multiply that 2 into both of these terms. 2 times y is 2y. 2 times negative 1/2, and I can do a little side calculation if we want over here. Negative 1/2, if I'm multiplying fractions, I multiply the tops. I get negative 2, I multiply the bottoms, I get 2. 2 divided by 2 is 1, so I just end up with a negative 1. Negative 1 x is equal to negative 14. Notice how negative 1 times x is just x. I'm going to rewrite that. 2y minus x is equal to negative 14. And I'm super close to being done, except we notice that the coefficient before x needs to be positive. So again, I can multiply everything on my left-hand side by something and everything on my right-hand side by something, and I'm allowed to do that. Take a second and think, what can I multiply my negative x by to make it positive? Keeping in mind that a negative times a negative will always be a positive. So what I can do is I can multiply it by negative 1. And again, I have to multiply both sides by the same thing. Negative 1 times 2y is a negative 2y. A negative 1 times negative x is a positive x, which is why we did the whole thing to start with. And that's going to be equal to a positive 14. In standard form, we should rearrange it so that it's ax plus by is equal to a constant. So my x term should go first, my y term should go second, and that should be equal to our constant. Done. Let's take a look at a couple of more examples. 5.1b. Find the slope and y-intercept of the following. So you will notice how both a and b are in which form? Yeah, so they're both in standard form. Standard form doesn't give us a lot of information right off the bat. So the first thing we're going to have to do is we're going to have to write them in y-intercept form, or sorry, slope-intercept form. So I have 4x minus 2y is equal to 8. And in order to get it into slope-intercept form, keep in mind that's y is equal to mx plus b. I want to get that y all by itself. So what I'm going to do to a is first I want to move that 4x away from it. So if I have a positive 4x, and I might just write this out so it's a little bit easier to see, 4x minus 2y is equal to 8, I can subtract 4x from both sides. Again, when I combine like terms, I've got a positive 4x and I've got a negative 4x. I combine these two things and they cancel out, and I end up with a negative 2y is equal to 8 minus 4x. Now, in order to get rid of this negative 2 that's with the y, this is a negative 2 times y. In order to move something or get rid of it, I have to do the opposite. So I'm going to divide both sides by negative 2. On the left-hand side, it's only one term, but on the right-hand side, I have to divide both terms by negative 2. I'm not allowed to do it to just one term. It has to be the whole side. On the left-hand side, negative 2 divided by negative 2 is 1. So I'm left with just y. On the right-hand side, I'm going to split this up. I can do this with fractions. 8 divided by negative 2 and negative 4x divided by negative 2. So that y is equal to 8 divided by negative 2 is a negative 4. Negative 4 divided by negative 2 is a positive 2. x. And again, I'm going to reorder this so that it looks like my slope-intercept form. Y is equal to 2x minus 4. And this is the glory of slope-intercept form, is once it's in this form, we can look at the coefficient. Maybe I'll change colors here just so it looks a little bit different. I didn't do that very gracefully. Maybe I won't change colors. Why won't it let me change colors? There we go. I'm going to do this in red. This coefficient in front of my x is always my slope. So my slope for this is 2. My y-intercept will always be this constant that's out at the end. So my y-intercept is going to be, and we can write this either way, my y-intercept is where the x value is 0 and my y value is b, which is the last coefficient. Or some people will just say b is equal to -4, and we know that that's the same thing. I'm going to go back to blue, and we're going to take a look at this second example. I've got a 4x plus 3y is equal to 0. Now would be a phenomenal time to get a piece of paper and a pencil, pause your video, and try this one all by yourself. And then once you're done, come back and watch this video and see if we ended up with the same answer. So what I'm going to do is I want to get, again, y all by itself. I'm going to try and get rid of this 4x. It's a positive 4x. So I'm going to subtract 4x from both sides. Positive 4x and a negative 4x is 0. I'm left with a 3y is equal to 0 minus 4x is just a negative 4x. My last step to get y all by itself is I'm going to have to divide by 3. I'm left with a y is equal to negative 4/3 x, and then I'm done. Notice how I did something a little bit cheeky here. I drew this fraction up top with the x on top, and then here I didn't. Those are the same things. If we were to do our fraction multiplication again, that would be a negative 4x divided by 3, but the bottom one is a bit more common. I'm going to switch back into red again just so that we can. Apparently I'm not going to. Never mind. So we can see what we're talking about. So this one's easy to see. The number in front of our x, the coefficient with our x term, is negative 4/3. That will be our slope. But we have no constant out in front to figure out what our y-intercept is. So we need to think critically what number could be there, but that we wouldn't need to write. And there's really two answers that people will typically give. One will be a 1 and one will be a 0. Notice how if I write a +1, I fundamentally change what's going on. But if I write a +0, that's the same, which means my y-intercept is going to be 0. Or if you want to write this out as an ordered pair, my x value for my y-intercept is always 0. And in this case, our y value is 0. So it's going to go through the origin. Second one, rewrite the slope-intercept equation in standard form. We already did a couple of these in the notes, but we're going to take another look at them because they're important anyway. I'm just going to rewrite them because I find they're a little bit nicer to read handwritten than they are typed up. So in slope-intercept, to write the equation in standard form, we have to solve for the constant first. That's what we're going to do first. So we want to get this 1 all by itself. The only thing on the same side as the 1 is the negative 3x. So I have to get rid of the negative 3x. It's a negative 3x. The opposite of negative 3x is positive 3x. And negative 3x plus positive 3x is 0. And I have to do the same thing to the left-hand side. I end up with a y plus 3x is equal to 1. So when I look at this, I have to remember my two rules. Are there any fractions? No, in this case, there's no fractions. Is the coefficient in front of x a positive or a negative number? It's not allowed to be negative. In this case, it's positive. It isn't written in order. Well, not yet, but it's really easy to write it in order. 3x plus y is equal to 1. I am done. Let's look at this second one. Put a b there. I should put a b there. Y is equal to, and I'm going to write this one out because it's a little bit gross when it's typed. Y equals 1/3 x plus 1/2 is what that is. So this is our constant, the 1/2. We're going to have to solve for half. We are going to get it all by itself, so we have to move the 1/3 x term. It's a positive 1/3 x, so I'm going to subtract 1/3 x from both sides. I got a positive 1/3 x and a negative 1/3 x, so on my left-hand side I have a y minus 1/3 x is equal to 1/2. So now in this time, unlike the first one, I have two fractions. We want to get rid of both of these fractions. So we need to think of a number that we could multiply both of these by to get rid of the fractions. And what we're going to look for, if we think back to the start of the year, is our lowest common multiple between 2 and 3. Keeping in mind that our multiples of 2 are 2, 4, 6, 8. And our multiples of 3 are 3, 6, 9, 12. You can see on both of them, our lowest common one is going to be 6. So we multiply everything in this whole expression by 6. I have to do 6 times y. 6y. I have to do 6 times 1/3 x. So I'm just going to do it without simplifying first. I end up with a 6 over 3x. And on my right-hand side, I end up with a 6 over 2. I can simplify these fractions. We always want to write them in lowest terms. 6 divided by 3 is 2. And 6 divided by 2 is 3. We end up with a negative x, so I'm going to multiply both sides again by -1 to make it positive. I end up with a negative 6y plus 2x is equal to -3, and then I'm going to rearrange them so that it's in the socially acceptable order. 2x minus 6y is equal to 3. Write the equation in slope-intercept form and standard form, and then we've got a little graph here, and I think this might actually be the last example of 5.1. What I want to remind you is that the easiest way to think about graphs is with slope-intercept form. And so all we have to do to find out what the equation is in slope-intercept form, because slope-intercept form is y is equal to mx plus b, is all we have to do is find m, which is the slope, and b, which is our y-intercept. So if I look at our graph, our y-intercept is super easy to find. It's going through the -2 right there. It is -2, so our b is going to be equal to -2. And we've done a ton of practice finding slopes. All I have to do is find two nice points. There's a really nice point. It goes through that mark really well. And then there's a really nice point as too. Notice how these points don't quite go through exactly, so they're not as good. So our rise, 1, 2, 3, maybe I'll write this out. M is equal to rise over run. M is equal to my rise, which I just counted as 3, and my run is 1, 2, 3, 4. Is that in lowest terms? Yeah, it sure is. So now all I do is I substitute my b value and my m value into y is equal to mx plus b. So y is equal to my slope, 3/4, x plus b, which is I got a plus, it's actually a -2. And that is in slope-intercept form. To get it into standard form, we're going to have to do what we just practiced doing. We're going to do some algebra. I'm going to start down here a little bit so that I give myself some space and I'm not crowding that graph, 3/4 x minus 2. So in order to get it into general form, all I have to do is solve for this constant. I'm going to move this 3/4 x to the other side by subtracting 3/4 x from both sides. And on my left-hand side, I end up with y minus 3/4 x is equal to, again, a positive 3/4 x and a negative 3/4 x is 0. So I'm just left with -2, which is what we want. So x has its coefficient is both a fraction and a negative. So I'm going to show you guys a bit of a trick. So in order to get rid of the fraction and make it positive all at once, in order to get rid of the fraction, I'm going to have to multiply it by its denominator, which is 4. But then in order to get rid of the negative, I can also multiply it by a negative. So if I multiply everything by a -4, it should, in one step, turn it to a positive and get rid of the fraction. If you want to keep doing it in 2 steps, feel free to do it. But if you understand what's happening and you think you can replicate it by yourself, try doing it in 1 step. I end up with a -4y minus, a negative times a negative is a plus 12 over 4x equals +8. I don't need to write the positive, I can just write the 8. I'm going to rewrite them in order and simplify at the same time. A 12 divided by 4 is a 3, so there's a 3x minus 4y is equal to 8. So there it is in standard form, and there it is in slope-intercept form. And I think that's about it for 5.1. Thank you for watching, and I just wanted to remind you guys a couple of keys for success. Number 1, you got to do the practice questions. If the things I'm saying make sense, that's phenomenal, but you still have to practice and make some mistakes on your own. And that goes along with number 2. If you get stuck, ask me questions, get in touch, write me an email, make an appointment, or leave a comment on the YouTube video. And step number 3 to success is look after yourself. Eat good food, get some exercise every day, and socialize as much as you can right now. I hope you guys are all doing well, and I will talk to you soon.